A very good morning. If you have just tuned in, thank you so much for joining us ahead of the weekend. This is your feel-good breakfast show, Expresso. Now, many of us have heard of the Big Bang Theory that's said to have spun our galaxy into existence with the sun at the center, perfectly positioned to give us just the right amount of warmth and light. Now, joining us this morning is Jonathan Weltman from the Foundation of Space Development in South Africa to help us understand some of the research behind some incredibly powerful storms that might have led to life. Now, we are talking about the faint young sun paradox. First up, what is that?
That's correct. Back in about 1972, Carl Sagan and some other physicists asked this very important question. How could it be that a sun that hadn't fully developed yet was warm enough to keep the oceans liquid? Everything should have been frozen over. So it's a bit of a paradox, as in why is there liquid water on Earth 3 billion years ago?
Because the sun was burning at about 70% back then to what it is now, yeah?
That's correct. And so we've discovered a type of solar flare called a superflare. And that might be the answer to this paradox.
Might. Might is not a scientific word, no, but we love these sorts of paradoxes in science because they really do strike debate. So how could this have led to life being born or being created on Earth? Set the scene.
A solar flare is basically just a release of energy from the sun. And often these solar flares are accompanied by something we call a coronal mass ejection, which is radiation, which flows across the solar system over all the planets and everything. And the belief is that that radiation can interact with our atmosphere. And when the planet was very young, it was able to get through the magnetosphere, which didn't exist then, and change the atmosphere of the Earth. And in that way, warm the Earth up and keep things liquid. Now, the superflare is something that is 10,000 times more powerful than the flares we see today. And we only know this exists because we have the Kepler telescope, which has been exploring the universe and looking at stars like ours.
Literally looked back through time, yeah.
Wow, and comparing them to when they were very young and seeing how they behaved, which tells us how our star might have behaved.
Talk to me about the time process, because in your mind, you know, the idea of a solar flare, it seems instantaneous and quick. Over what sort of time span would one of these super flares have happened, and how would that have translated into life? Talk to me about that timeline.
Well, solar flares happen all the time. And it takes about 2 days, believe it or not, for a solar flare's effects to reach Earth. Wow. And that's a normal solar flare. And a super flare can still happen about once every 100 years. But in a young star, a super flare can happen up to 10 times a day. And so when that was happening early on, about 3 billion years ago, these super flares affected our atmosphere, which was mainly carbon dioxide, and created a change in the atmosphere to release a lot of nitrous oxide. And that's 300 times more powerful as a greenhouse gas than the atmosphere we know today, which explains how the planet could be so warm. And a warm planet and liquid water is what leads to simple life, which is what leads to complex life.
Now, I know humanity's little slice of, the life story of our planet is very small. Do we need to be worried about a super flare? What does this mean for our environment moving forward?
Well, fortunately, as our planet has matured, we've developed something called a magnetosphere, which is from the electromagnetism of the planet,
body armor, yeah,
which kind of protects us. But we have an even greater body armor out of that called the Van Allen belts. And these actually trap a lot of the radiation coming through. So the effects that we saw early on in the life of our planet are very unlikely to happen today because we're protected by these Van Allen belts in the magnetosphere.
Count your lucky stars. Jonathan, thank you so much for joining us this morning. I've got a lot of tag words I'm going to go and research on Wikipedia and beyond this morning, but thank you so much for inspiring this imagination around science. We absolutely love it, man. Thank you so much.
Thanks for having me.
Oh, well, still lots coming your way. In fact, we're going to spread a little yellow love.